into it. All right, I'm not going to serve you base and height anymore. All right, you got to put a little more geometry into it to find these things. First thing, do I even want to? Yeah, let me talk about, before I get back, let's talk about this part right here. Again, I said I'm going to jump around. Let's talk about that right there. Okay, that piece I just pointed to from the center to the vertice has a name. You actually know the name. It's just you've always thought about it with circles instead. What do you think that's called? It's called a radius. Yeah, it's still a radius. I know your whole life you've only, oh, that's only for circles. Only for circles. Well, this is a radius as well. Comes from the vertice, drawn to the from the center to the vertice. That's a radius. All right, so I just want to introduce that because we're going to start seeing that in a second. All right, so anytime I have from center to vertice, it's called a radius. And yes, all of them are congruent in every polygon, just like the circle. So all these radii up here are all the same length. Okay. Go to problem number 2. We're going to start with problem number 2. Let's start with problem number 2. It says find the area of the square. All right, I have 2 different options right now. Can you guys just get rid of the using the triangles? We're just going to find the area of this. I want to see what you guys can do here. Find the area of that darn thing. All right, it is a square. So let's start getting our mind properties of a square. Let's just talk how to find the area of a square. I don't think I mentioned that, but it's a rectangle, right? Squares are rectangles. So area formula I'm going to need here. I don't need to introduce a new one because it's a square is a rectangle. So how can I find the area of this one here using what formula? Where are we going, Henry? Base times height. I use length times width, but Henry, that's fine. Base times height. And since this is a square, what do I know about the base and the height, or in this case, the length and the width? Since it's a square, what do I know about those 2 measurements right there, Alyssa? They're the same. So you find one side, we're good. So that's our goal right now. Find a side of the square. What did I give you? What's that 7 centimeters there we just talked about? That 7 centimeters is the what here? Brendan? That's the radius. Okay. Kind of want to leave it at that. I don't want to teach you anything new here. You just got to find the side of the square. All right, it's a square. And I just gave you the radius. You can draw in anything else you want to. All right, you can draw in anything else that you think may help you out. I want to help me find another side of the square. All right, because you find the side of the square, you got all sides. You know what? I'll give you a 2-minute. Talk it out in your group right now. How can I find the side of the square? Go ahead, talk it through right now. How can I find another side of the square? You can draw in other things too, guys. Remember, you can draw in other things. It's a square. All properties are there too. Find me a side of the square. Just knowing the radius is 7. Think you guys can do it? Use some use. I know that's easy to say, but you got a lot of properties you know about that square, and you were just introduced to a radius. Any group want to chime in here? You did have to draw in some other features, but because that alone won't cut it. Anything else you want to draw in? Any other groups want to take this here? So I see a lot of work being done. And there's multiple ways too. There's just not one go-to method here. Multiple ways how to get a side. Anybody want to go here? Go ahead, Dylan. What do you got? So you want, here's one method. All right, I don't know if I'm going to go with it, but yes, this is a method. You want to draw in the other radius going here because you know that's going to be 7 as well, right? For a total of 14. Where are you going now? Keep explaining. So right here? Yep. So you're doing pi tag. Okay, here's what Dylan and his group's doing. Hey, I know these are the same. So x squared plus x squared equals 14 squared. That's what they're doing. That's fine. Great. As long as you're all right with the algebra with it, that's fine too. All right, another method. All right, that I'm going to keep going with. Notice how Dylan drew in the one extended here. I could draw in another radius going to another vertex, right? Boom. How long is that radius? Also 7, yep. How do I know that's a right angle? It's a square. Any property exists, including diagonals are perpendicular. There you go. That's how I know it's a right triangle. Now I can do 7 squared plus 7 squared equals c squared, another version of Pythagorean theorem. All right, so go ahead, get me the side. I don't care what method you use. Go ahead, get me the side. I'm going to call on somebody in a second. Get me a side of the square. Radical form, please. And what is the side of the square in radical form for me when you have it? There we go, Bailey. 7 radical 2. And we already talked. All sides are equal, so if the length is 7 radical 2, so is the width. So what's the area of my square here now? Let's do it here. Area of the square going, Jonathan, 98. And everyone keep remembering your square centimeters. Put the units on there. We can do it. Okay, we can do it. All right, next one, number 3, the triangle. Let's go to the triangle now. Again, we're just going to find the area. I'm not going to do it using a different method here. All right, so we're just going to find, we know the area formula. All right, triangle area formula. Triangle area formula. Ooh, Cormac. Good job. 1/2 base times height, but we are not plugging in 4 anywhere there because the 4 is the what of the triangle. What's the 4 here, Jonathan? What's that 4? It's the radius. All right, so I'm not plugging it in for B or H. All right, can we draw in the height? All right, can we draw in the height? Probably we can draw it in from any vertex, but probably the easiest one, right, is always coming from the top down. And what do you know about that height? Heights are always what to the opposite side, since they're called altitudes too. They're always what to the opposite side. What else can I add in my diagram right now? Because that's the height. Dylan? They're perpendicular, so I could put right angles there. Yep, good job. Another question for you. I don't know how long the whole height is, but I know how long part of it is. Take a look. Part of that height, not the whole height. Agreed, not the whole height yet, but part of the height. How long is part of the height? Ooh, where are we going here? 1.5, Alexi. How long is part of the height? What's this right here, Alexi? From this center to that vertex. What do we call that? Yeah. So how long is it? Yeah, everyone. Hey, that part's 4. It's a radius. All right, part of the height's a radius. Now we got to find the other part right here, right there, so we can find the height and the base. What's up?
Is the height and altitude?
Yeah.
Does that mean that it's broken into what's it called? A ratio of 2 to 1?
Oh, you're thinking centroid. No, not unless that center's the centroid. Okay, so I don't. Good thought though. I like it a lot. Good thought. It might be actually the centroid now that I know it's coming up here. All right, it might be broken up, but not all the time. Okay, not all the time. All right, you ready to help me find the rest of this piece here? What type of triangle was this? Equilateral. Okay, so we know all sides are congruent. We always know that. The one piece you guys always forget, yes, all the sides are congruent, but so are the angles. What's each angle measurement up here then? Think about it. What's each angle measurement? They're all congruent. They're all congruent. What's each angle measurement in that triangle? Ooh, where are we going there? Lily? 60, right? 60. So this run right here, that's 60 degrees. Yep, that whole angle. Wild guess what the radius is doing to that angle. Oh, bisecting it into how many degrees now? This 60 degrees is getting bisected into two, what type of angles there, Henry? 30s, yeah. Oh, look where we're going, kids, aren't we? There's a 30. I have a right angle. What's got to be the other angle? 60. All right. Period 1, awful with the rules, by the way. The 30, 60, 90 rules, awful. Where's the 4 across from? Where's the radius of 4 across from there? Shar, where's the 4 across from? The 90. So that is the hypotenuse of the 30, 60, 90. Everyone agrees the hypotenuse? What was the rule of how to find the hypotenuse again? Hypotenuse equals shorter leg. Oh boy. Oh boy. What are we multiplying that by? Shorter leg? Alyssa?
Shorter leg times, is it the other leg?
Other leg. It's just a number.
Oh,
It's just a number. No. Shorter leg times 2. You double the shorter leg to get to the hypotenuse. Yes, everybody? Double the shorter. What is the hypotenuse again? It's 4. So what's the shorter leg then? What's my shorter leg? If the hypotenuse is 4, shorter leg must be, Drew? 2. Just using my rules. Okay, how long's my height now? How long's my height? Stellan?
6.
6. All right. So yeah, I guess it was a 2 to 1. I don't know if that works every time. I'll have to check that out. So 6. Everyone okay? Why it's 6? You ready for the base now? Which is, hey, take a look. The base is this whole side. I need to find that whole sideline. What's across from the 60 then? 2's the shorter leg. So what's the longer leg across from the 60? We're getting there. We're getting there slowly. We're getting there. Brendan, what's across? What do I have to do to the shorter leg to get to the longer one?
You gotta add it to like multiply by radical 2, 3. 3.
Yes. Multiply by radical 3. So that's 2 radical 3. Good job. Radical 2 is the 45, 45, 90. That's not my base, though. It's not my base. What do you think the height's doing down there, though? Bisecting it, yeah. So if that's 2 radical 3 on the other side, you got 2 radical 3. So somebody's going to find the whole base for me now, so I can plug it into my formula. What's the whole base length then, as you guys calculate there? Lily? 4 radical 3, good work. And what's it say? Leave your answer in simplest radical form. Good. When you have it, simplest radical form for me. Woo! Alyssa, redemption, simplest radical form. Okay. I look at my diagram, it has no units, so I wouldn't expect any units on yours. All right, look, you guys can find those, right? Square, triangle, no big deal. Here's the problem we're going to run into on our last one. What if I don't have a formula? Go back to problem number 1. Go back to problem number 1. What happens when I don't have a formula? What is this figure? What am I asking you to find the area of? Cormac?
Hexagon.
It is a hexagon. Anybody know that formula? Waiting. Me neither. If anybody wants to know, by the way, here you go. I pulled it up earlier. There you go, if you want to memorize that bad boy. 3 radical 3 divided by 2 times 1 of the sides squared. I don't think so. I'm out. I'm out. I'm not memorizing that. On top of what? The 7 other formulas I'm having you memorize for Monday? No, thanks. I'm good. All right, so what do I do when I don't have a formula? Okay, what do I do? Here's what's going to happen. All right, just let me do this on my diagram. I don't want you to mess up yours. What we can do is we can draw, when you draw in, watch what happens here. When you draw in all the radii, in this case, all 6 of them, everyone see you form 6 triangles. 6 what? Triangles? You guys know the area formula for a triangle? Yeah, and they're all congruent to each other. So here's our plan right now. I don't know the area formula for a hexagon. Not an excuse, I can still find it. Here's how. Find the area of one triangle, and then do what at the end? Multiply it by 6, because they're all equal. So that's what we're going to do here. I don't know the area of a hexagon. I'm not memorizing that weird formula. So I'm going to find the area of one triangle, and then at the end, multiply it by 6, because they're all congruent. All right, everyone all right with the plan? All right, help me find the area of triangle ABC then. Okay, let's find the area of triangle ABC so we can multiply it by 6. So we know it's area formula again for a triangle. Where am I? Here we are. Area formula for a triangle. Bailey?
1/2 base.
Yep. And then I'm just going to remind myself I need to take that answer and multiply it by 6 because there's 6 congruent triangles that make up the hexagon. Oh, you're welcome. I gave you one value already. What value are you plugging in and where are you plugging it into? Whew, going deep. Simon, what value did I give you?
3.
Okay, where's that going in? Good job, because that's the only number up there. Good job. Yep, way to go. And where's it going in for?
The base.
Yeah, you're good. Why the hesitation? You ready for the height now? We got it. Okay, now we got to do a little work for the height. Find me BD. How long is BD? All right, well, first of all, what do you think that height is doing to that 3? Because you'll be correct. Those 2 are congruent triangles. They're bisecting it. So on each side, you can put 1.5 or just on one side. I don't care. I'm just going to put it on one side here. So that's 1.5 on DC. Yep. All right, you ready for this? Go to central angle ABC. How can I find ABC? Remember, they're all congruent triangles. They're all congruent triangles, guys. How do you think I can find that little central angle ABC? The whole angle ABC. How can I find that one? Thoughts? They're all congruent, by the way. They're all congruent. All these 6 central angles are congruent. I just want to find the one here. Oh, Simon, back to you. Drop some knowledge on us. What do you think they all add up to, all 6 of them? If I...
360.
Oh, they do. And they're all congruent. So what do you want to do with 360?
60. Divided by 6.
There you go. All right, so ABC is 60. What do you think the height's doing to the 60 degrees? Bisecting it. Look what we have, kids. What do we have in our hands? I got a 30 up here and a 60 down there because the height bisects it. I got a 30, 60, 90. Yep. All right, go ahead. We've talked about the rules already. Find me the height, BD now. Knowing 1.5 is across from the 30, what's across from the 60? Using your rules, what's the height? I have 1.5 across from the 30. What's across from the 60? All right, what's the height of one of these triangles? Who are we going there? Lily, what's the height? 3 radical 3? Okay, be careful. Make sure you use the 30, 60, 90, right? I got 1. I don't have 3 anymore because it got bisected. I got 1.5, Lily, right? 1.5. That's the shorter leg.
Or 3 radical 3 divided by 2.
Yep, 1.5 radical 3
Oh,
then,
sorry.
right? Remember? Yeah, that's fine. You just take your, Lily, right? You take your shorter leg and multiply it by radical 3. That's it. So 1.5 radical 3, which is what you told me. Okay, everyone all right? That's 1 out of the 6. And then I got to remember to multiply my answer by 6 because there's 6 triangles there. And I'm leaving your answer in 2 different versions. Radical form and rounded to the nearest 10th. All right, what's your calc giving you for radical form? Leaving the radical in your answer. What are we looking at there? Simon, wow, unbelievable today. Never gets called on.
I didn't get radical form. How do you get it?
Type it in. What are you typing in your 1/2, right? Times 3 times 1 point radical 3 times 6. Did you change the language of your calculator? You good?
9 radical 3 divided by 4.
What? Here.
Just plug in a number anywhere.
Right? You got 1/2, right? Times. You got 3 times 1.5 radical 3 times 6, because there's 6 triangles.
27. Yeah. No, I got it.
We're good? Okay. What is that? Meters squared? And how about it in nearest tenth now? Nearest tenth. Boom, there we go. Jared, nearest tenth. Good. Tonight on your assignment, you should only be dealing with hexagons. Those are the only formulas you are not given. It might be tonight, square, triangle, hexagon. That's all you have. Tomorrow we'll get into the octagon, pentagon, where we're still going to make triangles. Wow, left you guys plenty of time.